Are you able to hear me? So hope you are clear with the concepts till what we have discussed until yesterday. Now, many a number of times, these things we can understand very practically, man, don't worry. Now, one of the question that comes from the basic beginner, sir, how I can identify overfitting? Means I applied an algorithm and I designed a model and I'm putting it for implementation. How I'll know my model is overfitting? The simple thing is your model is overfitting or not, you can always identify only when you're taking it in the production side on the real time cases. Am I clear? Means testing your model on the real time data only can tell you whether your model is overfitting or not. Understand very carefully. You will listen many number of times or you hear in the market much of times. Our company's artificial intelligence and ML projects are working very fine with greatest accuracy when we are working on POC, proof of concepts. But when we are putting them into the implementation, they are failing. Either they are failing because of the overfitting or they are failing because of underfitting. That's all. There are only two aspects here. Am I clear? So how I can know my model is overfitting? The model is performing very well on the training data. Means whatever kind of training data you're having, on that, it is technically working very well, returning a very lowest level of training error. Means your model is when you're putting your model for process of implementation in your development environment, you are getting 95, 98, 75, 80 percentage of the accuracy. But when you're taking this particular model and you're pushing it into the actual implementation, where validation or test data is implemented, it is returning high validation errors. Means high amount of validational failures are happening in the model. Means feature wise, you are getting more number of errors. But these features, when you're keeping in training area, you're not getting errors. Now, many a number of times, people who are not having clarity on this, what they will do is, whenever the model is failing in the production side, they will try to once again test the model in the development side. In your development side, you test 1,000 times, it will work. Why? Because you're having some data that is already refined and your training data is already polished. But the real data comes from where? When the system is operating. You know that AML implementations are for real time data. So when your data is taken in the real time, maybe some data is coming which you are unexpecting in the training side. And when such a data is coming, it is automatically going for a validational failures. Accuracy level of your model is decreasing very, very heavily. Then you should understand that there is some problem with your model in implementation where your cleaning of the data is not correct, identification of your data is not correct, your consolidation state of your data is not correct. Something is happening in the cleaning part, which is fundamentally not able to clean the data in a very proper validational state. Means there is some data that is coming in real time, which is out of your expectation. Identify that data. So how I can identify? The reason AI ML projects, they are highly implemented using what? Depending on log management. You should go and study the log files. There are many people who do not implement log management and they fundamentally practice. See, when we are learning AML, we don't use any log. Why we need any log management? Here, my job is to teach you algorithms, no? So, what you miss out of your classrooms, basically be very careful. So, when you go to the log, your log will contain millions of records. You should have patience of reading that corresponding logs. How much you can read out of a log when it is having millions of records out of one implementation? No human being can do that. So once again, what we should do? Log management, understanding, identifying, and decision making in log is also once again one automation project, one AI project in that. That's why AI projects, your final target to the client is one level of AI, man, but your product, how it is working autonomously, identifying that is another level of your project, what your team has to get ready. So try to understand these constructs. So these validation errors you have to track definitely and correct your particular model according to the new validations for which it has to get ready. So when overfitting of data happens, there's a large gap between training accuracy and validation accuracy. Means training accuracy and test accuracy, great lot of differences will come. You executed your model in your training environment, your model gave you 75% accuracy. Your client is saying that even 70 to 75% accuracy, if it is there, we are ready for accepting the project. Now, did you achieve your project to the client's expectation or not? Hello. Are you there and are you listening or not? So you have definitely achieved your project as per the client's expectation or not? Now you took the model and you fired in the real environment. Okay. In test environment, you fired your product and your product is fundamentally giving somewhere around 68% accuracy only. It is giving 68% accuracy only. Is this gap is very huge gap from the client's expectation? No, because client said 70 to 75 and your gap is 68 means 2% gap is there. So technically we can convince the client. But imagine your model when it is fired in the client's environment, actually it is giving you something around say like some 55 percentage. Now that is something that is really to be taken care of. Am I correct? That's first thing. So here your model is basically going with some kind of fitting status which is not acceptable. So this validation accuracy, if it is very high in gap, then technically you should understand that somewhere overfitting is taking place. Am I clear? Identify that. No model directly will tell you why it is overfitting. Because of which reasons. Now, reason identification is your core area of your expertise in the domain and the subject matter expertise what you have. And finally, you should have the ability of studying the real-time data that is coming when it is taken into the implementation. So you need other kind of skills, not just the programming skills when you're working in AML. Am I clear? So you cannot throw your product directly into subject matter experts domain and say, you please find and tell me. They say like, what is exactly expected to be part of the features for this particular model to work? We have already told you. Now, where it is going wrong, you find out that's your own headache, they will say. Be careful. Now, how to identify underfitting? Now, underfitting is basically something, it is happening at the level of the training level itself. Means in your development itself, you can find that happening. So underfitting projects, they never move into production side. Okay. Got it. So be very careful. So the model performs poorly on the training data, and even on, if on training data but is underfitting 150%, will it not underfit once again on test data also? Therefore, underfitting products, can you expect them to be taken to the client level discussions? No. What I mean to say is, your client expectation of the accuracy was 70 to 75 min. Now, when you're testing a particular model, it is giving you 68%. Can you dare to talk to your client that, sir, it's just 2% less than your actual execution of expectation? Let us take it to the production. Will the client accept? No way. Why? Because his vision is you produce the model at 70 to 75. Means on training itself, you are not getting the correct result. And when you put it onto the test data, means in the real-time data, can you expect that to give you anything that is superficial to actual accuracy? Can you expect that? No way. Because in your training itself, if it is failing, in test, it will never fail. It never succeeds. Be very clear about that. So when underfitting of the data is happening, there is little improvement in performance on the training progresses. Means as your training is progressing, there will be little amount of performance gain only, optimization gain, nothing more than that. Therefore, forget about your area of testing. So underfitting should be taken very seriously. In which area? Underfitting of your particular model should be taken very seriously. In which area? In your development process itself. Okay, means in the lab where you are testing your model, there itself you should check out. Are you getting me? Mean there is some problem in your overall algorithm and your methodology of your program itself. Overfitting you should always take care of where? From the implementation side. Are you getting me? From the user acceptance side, overfitting. Underfitting is purely before your model goes into the testing departments. Is that point clear to you? So that is a fundamental focusing point, man. How you can know whether your model is overfitting or underfitting? Simple question will ask you. Can you tell me with your experience how you'll try to identify whether a particular model is overfitting? Those 2 points, what I told you, if you tell in the interview, that's enough. Okay. Got it. So my course as it is going, man, it also prepares you not only for implementation, it also prepares you for preparing yourself for the interview patterns also. Please take care of that. Now, these things, wherever you go with any other algorithm I'm speaking, they will be the similar concepts. Are you getting me? This terminology will not change. Be very clear about that. Therefore, whenever I'm trying to introduce a particular terminology, don't think that the terminology is specific to that algorithm, it's specific to the AIML in the core. Is that point clear? Now, what are the next kind of algorithms that can be part of the decision making? Till now, we have been concentrating on which algorithms in decision making? Decision trees. Okay, don't forget decision trees. But only decision trees can they do every area of requirement to be satisfied in developing the applications? No. So the next category of algorithms that can come into your construct of decision making is neural networks. Means a more advanced area. So when you come to the neural networks, understand one thing, man, it is a computational model which is absolutely inspired by understanding the human being's brain. Where whenever you are trying to take any decision as a human being, you take the decision by one single thought, or you'll be having multiple levels of thoughts and you finally come to decision, man. Multiple levels, yes or no? Without your knowledge, multiple levels of decisions are happening. And in those levels of decisions that are happening are interconnected, and finally you'll come to one conclusion, yes or no? Neural networks is a decision-making algorithmic process which is very nearest to the human being's brain, which is a computational model inspired by human being's brain, consisting of layers of interconnected nodes, which are called as neurons, which can learn to perform tasks by adjusting weights between the nodes. One simple thing I'll tell you, you're walking on the road, man. Okay, you're walking on the road with your natural style of speed. Suddenly, you found that in a particular place, means around, say, like 2 meters ahead of you, your eyes have identified that the road is muddy and it is fundamentally wet. Then don't you think that automatically you're sending signals to your particular brain, and your brain is immediately trying to tell you, please control the speed of your walking and the style of putting your foot also, it will tell you to take care. Your hands immediately go down and catch your fan, and you'll raise the sleeves of your plant, and you try to take very careful steps in such a way that first thing, the water is not spilling on you, the mud is not coming onto your slippers. The third, you're taking much of care, you're not slipping and you're falling away, yes or no? But all these things are happening with the multiple layers of decisions that have happened in between your neurons. And these neurons, are they not sending instructions to your legs and your hands and your eyes, and your whole body is technically trying to take much of control to see that you're not losing your center of gravity? So which part of the body should adjust in which way? For everything that is happening in your body, there is a criteria and composition of some priority, yes or no? And according that, each body of your part is responding in that activity. Do you agree with me? It's not this is happening when you're driving your two-wheeler, when you're technically trying to go on the road, suddenly you find you're finding one bend of the road, let us say. Are you not immediately catching hold of your brakes to a particular extent? And then technically, if you're on a two-wheeler, your two legs are coming out of the vehicle and they are keeping themselves very nearer to the ground, and you're trying to bend your vehicle a particular amount of angle such that you're keeping the banking very safe, and the acceleration is coming down very perfectly to adjust the speed according to that particular banking, and you're taking the turn or not. Now, I don't think all these things are there as part of the vehicle. Do you have this intelligence in the vehicle? No. This whole intelligence is coming out of your brain, and this is happening because of multiple times you have been riding the vehicle, and your experience of riding the vehicle on different kinds of roads and situations, is it not making you get through that expertise and experience of controlling the acceleration, brake, your legs hanging out of your particular vehicle, your body bending as per that particular banking of that particular road, and the speed? These all things are coming out of experience, or just one day suddenly it comes into your brain? Out of experience means every time you're learning. Am I correct? Every time you're learning. Either learning from your own experience or learning from the other object's experience, which is basically identified with. Neural networks are more intelligent level of artificial intelligence areas for decision making. Clear? How neural networks actually work? The input data, it will pass through several layers. Your data is not passing in one layer. See, when you're walking on the road, after 2 meters, you're finding a wet area of the ground. Your eyes are not only seeing that it's wet, man. Your eyes are sending the data to the brain. It is wet. It is having some amount of water here and there. I have seen some mud also, which is very thick and it is basically semi-solid and it is raised in that particular process. And somewhere I can see some green patches which are indicating that there is some amount of fungus that is there which can be more slippery. So much information it is sending you, yes or no? And without keeping your leg into the water, your eyes are able to predict how much deep that water could be there and giving instructions to your brain clearly, this much of depth that water could be there. See, your data is coming, your raw data comes, your input data comes, but your input data passes through several layers where each layer extracts more complex features. So you're taking the data, you're subdividing the data into multiple different number of layers of features. And in each layer, you're getting few more features. And those features are studying the data once again in a different state of its properties. And your decision is taken in your brain. The final layer produces the output, which can be like a decision or classification. Very, very interesting construct, man. This is an area where the world is definitely promising that AI can give solutions as perfectly as human beings can take a decision. But studying and understanding the human brain is not that easy, man. The world level researchers say that out of the entire intelligence and complications what your human being brain is having, we understood only 0.2 percentage of its ability till now. 0.2%. Just imagine if human beings can utilize another 0.1 to 1 percentage of the human beings brain's intelligence into the construct of AI. Trust me, you'll definitely have machines that oversmart the human beings and they will work. Be very, very clear about that. Therefore, neural network might classify from very simple projects like image processing between cats and dogs after being trained on labeled data, which is the most simplest project many people will speak. By taking the images, it can tell you male and female after being trained on labeled data. I think nowadays, mobile cameras, when you try to take a selfie or anything or a group of photographs, is it not trying to identify the genderman? Are you not getting in your camera on that square boxes somewhere beside that male, female indication? How is it that your camera lens is having the intelligence of recognizing only because of the face male and female? It's not the lens. It is a chip that is designed with neural intelligence internally. And I think going deep is not a cameras are telling you the biological age also sometimes. Hello. Maybe it's not exactly correct. With your physical age to the biological age, there will be difference, man. Definitely. So physical age is calculated in the construct of what? The number of years since you have been born. Biological age is taken care of with the kind of body language and your BMI factors that are studied through your face directly. Means the glow, the skin, select glow, what you're having, according that it will decide. What is your actual biological age? Means you could be 50 years, but your camera is saying that you're 40 years, means your physical age is 50, but you're maintaining your body with a fitting state up to 40 years now. Means your internal organs are working at 40 years age. It's good. Star and planet after being trained on labeled data. It can tell you very clearly, your telescopes. I don't know whether you have seen through the intelligent telescopes that are available in the markets today. It can tell you the difference between a planet and a star after you focus it. It can tell you the vehicle type after being trained on labeled data. This is the same kind of project that was implemented during the COVID season, where the people, when they were in the group, they are wearing the mask or they are not wearing the mask has been identified. This is the same project that is used by the traffic departments to check your vehicle speed is according to the speed limit or not. So many projects. So nearest to the human being's intelligence, they will work. Are you getting me? There are many number of projects in this construction. Just I gave you a few ideas which are very basic. So when you're taking the algorithms in decision making, what are the advantages? Can model complex patterns and non-linear relationships. Okay, even if the data is not in a relational state also, on the non-linear relationships also, it can identify the state of the object. It is great area for image recognition, speech recognition like environments. There are certain disadvantages also by neural networks. What is that? The only disadvantage is the more the data you feed, the more the kind of decision it can take. More the data you're feeding means what? More computational power you need. Okay, you cannot do these projects on your CPUs. You need special kind of components called as GPUs. Are you getting me? So they need a very huge amount of computational power. That is the reason the world is moving towards what? Quantum computing. Okay. Quantum computing will be working on qubits, which are basically much powerful for analyzing the data in multi-dimensional state of architecture. So the next generation future, if quantum computing is very properly developed, and if it is coming into the picture of implementation, you can just imagine. That's what I'm saying. You will find systems that can equivalently behave or over smartly behave like human beings in the coming days. China-like countries are doing great projects, I'm telling you. You cannot even believe, I'm telling you. They are totally thinking of replacing the traffic policing system with human being, means removing human beings. They're already in a plan. Recent test has been conducted where a robotic traffic police will control the total amount of traffic. Not only that, violators are automatically taken with a photograph, analyzed. Data is sent to the central station where they have a traffic challaning system, and the system automatically operates, issuing the challan to the corresponding person. And they are trying to integrate that particular person's bank accounts, where these bank accounts will be integrated, and even before you pay the challan is deducted automatically. You just imagine the process what they are thinking. It may be a country what you may not like, but the kind of projects. So computational power could be very large. It's in testing, man. But imagine if the computational power is available, don't you think that in next 10 years you don't find a traffic police on the streets now? One area of work is eliminated. Finish. See, why I need a postgraduate or graduate who really learned so many things in his life, has written the toughest exam of competition, and is coming and standing in the middle of 4 junctions and only to control the traffic. Man, are we using this intelligence of this gentleman anywhere to the prosperity of the country? No. Replace that. That person you are thinking that people generally, when they speak to me, they say like, sir, poor traffic police, he will lose his job. He may lose that job, but using his intelligence, he should work in some other area to prove his intelligence, not to stay on that particular road for 35 years of his service, only controlling the traffic. That's how AI replaces the human beings. Doesn't mean that human beings are losing the work. That area doesn't need a human being anymore. So then people depending on that job, what they should do, think of alternate jobs. Think which is more better job for you. That's all. This will happen. You wait and check. The security guards standing in front of the retail outlet stores, they will not have any more jobs. Because of neural networks and quantum computing comes into the picture, these all areas will get substituted by robots. Difficult to interpret the reasoning behind the decision as it is black box model. No doubt, reasoning is very critical. But if I can go on making the model to take the data and self-learn, don't you think that it is going to come into a very intelligent model after some time? Generative AI. If I can develop the first level AI model, after that, if I push that particular object into generative AI, don't you think that will go on increasing its intelligence slowly? And after 4 or 5 years of its work there, it will work more intelligently than a human being. Am I correct? People are talking about generative AI, man. If AI is not developed, where is generative AI? If generative AI is not there, where is agentic AI? So don't you think that people thinking of working on generative AI directly, they are end users of AI? Hello. People are talking about agentic AI. Are they not end users of generative AI? When you become an end user, your work becomes more simple or more complicated. Tell me, more simple. Now, more simple work, if you can do, somebody else also can do after 6 months. Why I should keep you? So we will be concentrating in our class on core AI. Are you getting me? Such that you can work in any other AI as you like. I don't care about that. Is that point clear to you? So try to understand my approach. Now here also once again, the same terminology comes when the terminology, what we have been talking about in the previous case, like underfitting, or that is same and that definitions never change. Therefore, I'm not going to repeat on those terms once again. Is that point clear to you? Once I cover certain terms in previous constructs, those terms I'm not going to repeat anywhere. Here also we need data. What kind of data will be there? Numerical data, categorical data. Numerical data will be how many times? Discrete and continuous. Categorical will be on what times? Nominal and ordinal. So we don't need to repeat those points once again. Is that point clear to you? That's how I'll be saving my time as I'm speaking with you. Now, with only neural networks, can we achieve all the best decisions to be taken, man? No. That's where in decision making, there's one more category of algorithms, man, that is reinforcement learning. Now, reinforcement learning is what? What's the difference between neural and reinforcement? So, neural itself, you said it's an intelligence, but technically, how reinforcement can be better? Neural is having one fundamental limitation. What is that? Can you tell me? Tell me. Can you just think? It works only depending upon the data what you feed. Okay? It can work and it can give you decisions on the data what you feed. If your data what you're feeding is not sufficiently enough to understand the layers of features, don't you think that your decisions can come wrong? So try to understand one thing. Let us take a simple example of image processing. Okay. I've designed one product which can tell me whether it is a dog or it is a cat or anything. Wonderfully working. I gave a dog image. It said dog. I gave a cat image. It gave cat. Wonderful. I gave a cat image. It said cat. I gave an elephant image. It said elephant. It's wonderful. Now, I gave a cat image and then I gave a hippopotamus image. It may not tell you because hippopotamus features I have not feed into my neural system. Is that point clear? Second thing, I gave a dog image and I gave a wolf image. Dogs and wolves, they look similar or not? I don't know whether you have seen or not. They look similar, yes or no? Now, technically, I gave an image of a dog and a wolf. Then there is a chance that it can tell wolf is also a dog or dog is also a wolf. Yes or no, depending upon the data what I fed. So neural networks certain times can do the same mistakes what human beings will do. Okay? You try to test this man, go into any deep forest where wolves are there. The moment you see the wolf, you cannot recognize it's a wolf. Until and unless it never opens its teeth very wild and it does not howls. Dogs will bark, wolves will howl. You also get confused. Be very clear. There are many number of cases where you cannot identify the difference between a panther and cheetah. The human being's neural network will do that mistake. But all human beings will never do that mistake. If you're having a forest guard, he will never do that mistake. Why? Because he has been part of the domain, he learned the differences. Am I clear? Or not only forest guard, if you're talking to any particular tribal who is part of the forest, who has been living in the forest, they will never do the mistake. So that problem is there in neural networks. So neural networks have to be given new data every time as it is coming. Are you getting me? The next level of the advancement of neural networks is reinforcement. What neural reinforcement will do? It is one kind of machine learning. Now, till neural networks and decision trees, it is which kind of area of project? AI. There is no ML in that. Are you getting me? Learning is not there. What you give, it will speak according to that. Am I clear? Now, coming to reinforcement learning, it is a AI with ML, where you will be having agent learners, where the AI ML model, what you're designing here, that agent learns to make decisions by interacting with an environment and receiving feedback in the form of rewards or penalties. Means it will be having intelligence to study its internal environment or external environments, find the differences, and on the differences, it will start learning. It's as simple as I'll tell you. Now, suppose say like you are having a child, man, okay? You showed your child this is a dog. The child learned it is a dog, and you are telling your child the dog features. Mouth will be like this, legs will be like this, it has a tail at the back, it barks. So many things you have said. So your child caught that particular object as a dog. Yes or no? Hello. So he learned. His neural network is now ready to identify that as a dog. One day you and your child are walking on the road, man. Now your child is a curious child, let us say. He saw a cat. Now, don't you think that his neural network system is confused now? Then either he will try to ignore that cat and thinks that, oh, why the hell I should know about this? What I will get. Now, as a father, you are expecting that he should know that there are two objects that are working here with their communicative state of psychological interpretation. Your child is a curious child, then your child will immediately ask you, oh, Papa, what is that? Yes or no? Means it questions the system in experience. Means either it is contacting you. Environment means you are one environment as a father there. Another thing can be a teacher in the school or a book, whatever it is, some environment. From that environment, it will try to learn. Are you getting me? It will try to learn and immediately distinguishes the object. Is it not making some self-learning approach to become more intelligent day by day as new data is coming? This is reinforcement learning when what actually generative AI speaks. If first level AI is not given, where is the concept of generative AI? Man, people say like, I want to become a generative AI specialist. Gentlemen, first understand what is the difference between decision trees, neural networks, reinforcement learning. Using some tool that is already having intelligence and making yourself get through the construct is not really great. See, many people they are doing the same mistake once again. Let AI become very easy, then I will come and do my job. You don't need to do, man. Why? Because first project you will do, second project it becomes automatically more intelligent. You are removed. So it is basically a kind of machine learning environment where the agent starts learning to make decisions by interacting with an environment and receiving feedback in the form of rewards or penalties. Here, rewards or penalties means it's nothing but we are trying to tell that object, you are wrong, you are correct. Telling you are wrong is a penalty, such that it can learn better. You are correct, giving a reward. Reward means it will remember that particular object perfectly. Say like the same thing happens with you. Your child has saw the dog, it is identifying. The child saw the cat for the first time and is asking or she is asking, what is that? You gave him the intelligence of cat. Now, next time when you're walking on the road, once again, when he or she finds a cat, she's asking you, what is this? Means there is some problem in keeping that object state remembering in the brain. Now, as a father, now you need to make this object to remember. So, are you not trying to say that next time if you don't remember this as a cat, I will not take you outside? You're not coming along with me outside. That is like a penalty. Yes or no? Then the child thinks now, no, going with my father outside is a entertainment and an enjoyable situation for me. Then he or she will remember. Second time you're telling your child, this is a cat, I already told you. If you remember this in your life, I will give you a chocolate. That is a reward. Either a penalty or reward should make the system to understand what it is for the next time. Am I clear? So you need to understand that. So when you are trying to design a criteria of a AI implementation, in AI we give a model, man. When you come to the machine learning, using that model, it continuously learns and it develops an agent. Where the job of that agent is like what? One of the layer of your brain. And that agent will help now. That agent will help. Whenever the agent is unable to identify the object that is fundamentally registered in its intelligence, the agent will try to raise a question to the environment in which it is working. That question can be in the form of what? A message to the end user. This object is not found. This object is not identified. Then don't you think that as a father, you should tell once again such that it can take, means you should understand which features are missing, why it is unable to identify, add those features into the system of the data. The next time it will identify automatically or not. Same like a human being's environment, man. Same like a human being's environment. So how exactly reinforcement learning will work? The agent will take actions, observes the environment's response, and then adjusts a strategy to maximize the learning long-term rewards. So here, building a intelligent agent is very important or not? So do try to understand these factors, man. This is an area where you get environments which are called as self-learning. Am I clear? Self-learning environments will come from here. So because of reinforcement learning only, you're having, tell me, self-driving cars. Is it point clear to you? But this project has not started suddenly today. So first it started as what, man? Decision trees. Then they improved that into neural networks. Now they pushed into what? Reinforcement learning. And through reinforcement learning, don't you think that the self-driving cars are becoming more intelligent day by day? So this is a basic track, man. This is a basic track. So the very simple examples, I don't think I need to tell you now. Okay? Robots will always learn navigate to a maze receiving positive rewards. Your gaming applications is not a game is technically more intelligent to work. Online games you watch very carefully. First time you may win the game, but second time don't you think that your game is becoming tough to you? Why? Because it is understanding how you play, how you play. So that system is getting updated. That's the reason in online gaming, don't you think that it'll ask you to register and log with a particular name, username? Am I correct? Why, man? Means that user's intelligence in understanding that game is how much your agent is learning. Therefore, second time when you connect to that particular game, it never lets you win. So remember that. Therefore, can you become a master in your chess in one single day? No. Are you not learning day by day? Same way. Self-driving cars, another best example in and around you, which are basically trying to take decisions on the constructs of accelerating, braking, turning, margining. So many things are there. So self-driving automatically receives rewards or penalties. Positive reward when safely driving through a green light. A negative reward colliding with another vehicle or running a red light. So depending upon that, the system will automatically starts adjusting its intelligence and it's going on moving. Why penalties are imposed in your day-to-day life in traffic system? So that you don't do that mistake once again, yes or no? Sir, only penalties are the rewards are not. The rewards need not be given. Why? Because that is not your own family to give you reward. You're going say reward is nothing but your safety, safe driving. Penalty is to see that you're not losing your safety. Understand that. So the car is adjusting its driving strategy over time to minimize the safety and efficiency or not. So the maximum safety is achieved only because of learning. So today's self-driving car can be more wonderful with higher safety standards by next year. All human beings are equally intelligent. But don't you think that few human beings are definitely encountering when they are driving their car with accidents? So you can't expect every time that kind of safety. So maximizing the safety is on time span. Do you agree with me? The same thing here also. Reinforcement learning will make the world slowly move towards Watman, developing machines which are equivalent in thought process to human beings, where they take self decisions. Is that point clear to you? So daily we will be moving in reinforcement learning. Daily we are moving from one level of AI in expert to another level of AI in expert state. So expert AI systems are going on developing now. Imagine a span of 100 years continues like this. Then after that, just imagine the kind of world of human beings and machines. Advantages suitable for complex and dynamic environments. Learns optimal strategies through trial and error methods. What are the disadvantages? It requires more amount of training to perform well. More amount of training means what? More amount of new data. More amount of data for reinforcement itself. Means can you test this reinforcement learning projects, keeping them in the labs? Hello. No, you should leave them into the real world. But leaving that into the real world, don't you think that there can be a great lot of damage if the machine is taking wrong decisions? So reinforcement learning projects, they need real testing on humans directly and humans' environments directly. But this is really dangerous. The reason, another part of the world in AI is what? Simulation world. Are you getting me? There's another kind of world called a simulation world. Means, can we design simulators? Disadvantages, if you take it seriously, difficulty to apply in environments with delayed rewards or sparse feedback. Where feedbacks are not coming, then definitely it will fail. It will fail. So when you take decision making projects, they are generally done in how many ways, man? 3 ways. First way is what? Decision trees. Second is neural networks. Third is reinforcement. Is that point clear to you? So agent is nothing but something like you. Environment is nothing but external. Am I clear? Is that point clear, gentlemen? So providing the environment for reinforcement learning projects is really difficult in certain areas or not? So there are challenges, man. Leaving all these challenges, people come and tell that if I learn this tool, I will become. See, that's what I said. The day when you join my sessions, you want to be AI engineers or you want to be AI general developers or AI end users. Decide that. At least a developer is better, even if you're not an AI engineer. But don't go into the construct of becoming an end user of AI, directly talking about generative AI, agentic AI. These are all very simple terms in the market, and which is you lose money and we make money out of that. No. Keeping yourself here, you can work for any kind of AI in future. Are you getting me? Keep that spirit. By the time we are catching up with the next category of AI projects or what? After decision making, what are the next level of projects that are existing for AI? Let us see. Feeling interested? Let us see next 24 hours what is waiting for us, man. Keep that spirit. By the time I'll catch you in tomorrow's session. Thank you very much, gentlemen. Once again with you tomorrow. Have a nice day. Take care of yourself. Tomorrow we are having a session, man. Okay? Thank you.